In order to understand how Ruby organizes classes, it's helpful to look at what's called the inheritance hierarchy. We've seen a couple of examples of inheritance before in the context of model objects and controllers. So in this case, I just want to look at one of the default classes in Ruby, namely a string. As we've seen, the class of the string is just class string. But if we want to see what string inherits from, we can use another method called superclass. We can chain this. You can see that the string superclass is object. There's actually one more. There's basic object, and then at the end of that is nil, which means that there is no superclass for basic object. So let's take a look at a diagram that helps visualize this. This is the inheritance hierarchy for string. We can move this over a little bit so we can see everything there. So string inherits from object, which inherits from basic object. So this is what it means to say in Ruby that everything is an object. Everything ultimately inherits from object and thence from basic object. What this means in practical terms is that methods like the nil question mark method, which are defined in object, are automatically available on instances of the string class. That's the basic idea behind inheritance. To understand classes better, let's make some of our own. I'm going to make a word class. You can see that classes should be capitalized. And I'm going to define an instance method. It's going to be a Boolean method called palindrome that takes in a string and returns true if the string is a palindrome, that is to say if it's the same forwards and backwards, and false otherwise. And the way to do that is to say, well, is the string equal to its own reverse? So let's instantiate a new instance of the word class. W is a word. And let's see if, well, see if foobar is a palindrome. It's not. What about the word level? It is. Look at that. Now in this context, you might wonder, why is it that we're passing a string as an argument? Why not just make a word a string so that we could then instantiate a new word object and then just call w.palindrome without this part? Let's see how that might work. So what we want is for a word to be a string. Another way to say that is a word is a string. And when you have an is-a relationship like that, it's a case for inheritance. Now in this case, what we need to do is get rid of the current definition of word. There's actually a way to do this right in the console, but it's a little advanced, so I'm just going to show you the easy way, which is to exit. You can do exit, just type it out, or Control D, which is what I did there, and then restart it. That cleared out our previous definition, so now we can do class word. Instead of just by itself, we're going to say that inherits from string. I'll put in a documentation comment. So this is now a string, this word. I mean, words are strings. So you might ask, well, if we don't have an argument, if we don't have like a string variable, how do we compare the string to its own reverse? And the answer is that inside of this class, we have access to the string, which is to say the word, through the variable called self. This is a special variable, self, and we can say, well, is self equal to its own reverse? If that's true, it's a palindrome. So let's test this out. We can say s equals word.new. We can instantiate it with, remember we saw how to do string.new and then a literal string. Let's try this here. Now that's false. So you can see now that the s here is actually a word. So in fact, let's call it w. Let's do this. And let's make something that is a palindrome. We saw that level is a palindrome. So inside of this class, self is level. It's this string. And in this context, we can ask what class W is. It's a word. And its superclass is string. So it's inheriting from string, and indeed it has the following hierarchy. So word inherits from string, which inherits from object, which inherits from basic object. So you can see this is just the same, except we've added word at the bottom. By the way, inside of a class like this, you can actually omit self dot. We need self here because otherwise there's no way to know what we're referring to, but we can actually omit self dot and just say reverse, so this would work too. Actually, it might complain here that it already exists. No, looks like that worked. Oh, it's because, I think it's because this is exactly the same. Before it wouldn't have worked. So now we can do this. There we go. So the self dot is implicit when it's an instance method like reverse. Of course, words are different from strings in that they have this extra method, the palindrome method, but because of inheritance, words have all of the normal string methods as well. So we can do something like this. Do the length. We can calculate the reverse, and so on. And in fact, the reason that we were able to use reverse inside of the palindrome method is because words are strings.